our next speaker is and what he has in store for us. The next speaker for today is a researcher, writer and technologist who is currently associated with the Amadeus Labs. He has 2 patent publications granted and 3 more filed in the areas of voice recognition, classification and mobile app development for enterprise scale. Today he will be speaking about quality and testing of predictive analytics and big data applications.
With a huge round of applause, let's welcome Mr. Bhaskar on stage.
You'll get a little bit of sense of it. How many of you here do machine learning, big data application testing? Can you raise your hands? How many of you used it? Big data applications, anything? Machine learning applications? Can you give me an example of any big data application that you have used? What about Amazon.com? How many of you use Amazon.com? Amazon.in to buy? What is it? It learns what you are doing. It learns what your behavior is. It learns everything. So in day-to-day life, it is kind of interweaved into your day-to-day life. So you don't need to go anywhere. Look at Amazon.com or even Flipkart.com. Okay, so a little bit about me. So I am a PhD student in IIITB, Bangalore, and also director in Amadeus, where I do search, shopping, development. I work in the travel industry, and I have patents, publications. So that's a little bit about me. I like to travel, so I love Bhubaneswar. I see Puri and Konark. It was marvelous. Okay, so a little bit of inspiration for you to start with. So this is a robot called Sandfleet by a company called Boston Dynamics. Watch it carefully, it has a quiz question. So I need to give goodies to you. Okay, before I go on the video, how do you test this? Can any tester here tell me how do you test this? This robot just sees an obstacle. It has a camera and it jumps to the cliff. I think you can see the test data was a normal building, a 2-story building. Now you see in a terrain like a mountain and it jumps over it. Can you tell me how do you test this?
I would put up a glass in front of me.
Okay, no, I'm just asking about how do you test this. You're not going to test this real world testing. It's in the lab, how do you test this? Or let me ask you a very simple question. What is the path it follows? Projectile. Who said projectile? You said projectile. You know what is the equation of a projectile? Okay. So it uses the path of the projectile. So as a tester, you should know the camera, how much is the distance in front of you. You launch at an angle and it goes onto the top of it with a velocity. Right? That's how we test this, right? And coming to the data patterns, which patterns that Rahul talked about, I'm going to extend it a little bit, and because he made my job a little bit easier. So the agenda is going to be intro to the predictive applications, and then going to be a little discussing about key problems and challenges. A little bit of 2-3 case studies based on the time that we have, and when you walk out of the room, what do you really walk out of this? And we can take up questions. Okay. So what is predictive applications? So it has a lot of data. Data is the way to go. So you have a lot of data. It's complex. Complexity of the data. And 4 V's that you know is volume, velocity, variety, and veracity. So, and more importantly, you need to know what are the patterns that are associated with it, right? So you have a lot of patterns, and you need to be a powerful anthropologist. What is anthropology? It's about observations. Say, for example, you watch something, you like to observe. So anthropology is a person who sits there and observes the thing and understand what really matters. And second is the processing. How many of you work in traditional BI applications, the data warehousing, reporting kind of applications? Okay. So you might ask, what is different than predictive application? In my view, it is quite the same. And traditionally, we do data mining, etc., etc. We never face this kind of data or volumes. Now we have huge volumes of data. So it's pretty much evolution of BI into predictive analytic applications, right? And one size doesn't fit all. Please understand, as a tester, when you walk out of the room, when you're working on a predictive application, you cannot use it. Maybe the algorithm with Flipkart and Amazon may be the same, but it doesn't fit all. The one size doesn't fit all. They have their separate algorithms. Okay, the third thing is about the insights. What you have is intelligence and intuitiveness. So you have a lot of mathematical models and then thinking probability. How many of you like probability in your classes? Probability in statistics? Raise your hands. 1, 2, 3.
Never understood.
Never understood? Now you'll understand it. I'm going to give you some examples to understand. So there are 3 types of learning, right? One is called supervised learning, reinforced learning, and unsupervised learning. I'll come to that a bit with an example, and again it's a quiz question. If you give me a right answer, probably give a name, the organizer will get a goodie. So a bit of the learning types. So this is what the robot sitting in front of the computer want to learn about this. Let's take an example of this. WTC, you're in New York, September 11. How many of you remember 9 WTC attack? Okay, good amount of. So you're walking in New York Street at 7:30 a.m. What is the probability of attacking the World Trade Center Tower number 1? Whoever gives the right answer or closest right answer going to get a gift. 1 out of 1 probability.
50%.
Cool. No, it was attacked. But I'm saying you're walking at 7:30. It was attacked at 8:05 or 8:50. 15, no, sorry. No. I think you're going to get a goodie. Take a guess. Okay, so I mean, it's less than 0.001%. Nobody even believed that it would have got attacked. Now, at least the second question, if you can answer right, then I will probably consider giving the gift. So, the WTC Tower 1 attacked. Now, WTC Tower 2. What is the probability? 1? Who said 1 by 2? Raise your hand. So, your name? Subhashish. So, he gets a goodie. Why?
Because Tower 1 was attacked, so probably the terrorists must have planned to attack Tower 2.
That's right. This is called prior probability. And this is used, have you seen? This is used in something called Bayes theorem. Heard this vaguely? Bayes theorem? A little bit of Bayes. This is called name-Bayes theorem. It says that if there is an event that happened before, there's a good chance that the event gets recurred. So in this case, it's going to be 0.5. So and you can read a book called The Signal and Noise, which is by Matt Silver. You can note down, it's an excellent book. It gives you election predictions of Obama, WTC attack, etc., etc. I hope he predicts Clinton and Trump this time. Okay, so this is a form of supervised learning where you have prior data and you have name-based or random forest or a lot of algorithms to learn. Second thing is cycling. Okay, no guess for this. So I'm going to talk about when you learn to cycle. There are a set of rules and actions. Say for example, you need to hold the handlebar straight. You cannot take like this. You cannot bend your body like this. These are rules. If you violate the rule, there is an action taken and the consequence. So for example, the kids learn by adjusting itself and they fell down, etc., etc., right? So this is called reinforcement learning. Reinforcement learning is about rules, actions, and consequences. So if you break the rule or if you honor the rule, this is what you get and this is what the consequences are. Okay? This is reinforcement learning. Let's look at this. This is unsupervised learning, where you have a photo tagging. Right? Photo tagging is about, it tries to recognize your face, where you are, or your friends, where they are, etc. And it tries to do something like analysis to find out the square, where your teeth are, where your eyes, nose, etc., etc. And believe me, Facebook does this in around 1 billion images per day, and it's all live. It doesn't do any of this. And can you give training data set? Okay, this is Hari. Give all the data and then you learn? No, it doesn't do that way. It uses something called neural networks. Some of you learned who are ComC guys, computer science, neural networks, anybody? So they use deep neural networks, variation neural networks to do this. So this is a little bit of a thing on the machine learning. Now let's understand a bit of what is training and what is prediction, right? So let me give an intuitive example with this. A training is basically where you get a lot of data and the machine learns by itself, and that is what is called features and uses algorithms after that. When you give the next input data, it predicts. In the earlier case, when I wanted to took a WTC attack. The WTC attack 1 has happened. Now the second data is going to say that, okay, there's a 50% probability. I'm going to say it is going to be attacked or not going to be attacked. So you're training the machine invariably with your data sets, and the algorithm automatically takes care of it. A very intuitive example. Anybody can think of a real world learning by a machine, which you use, I mean, all of us use every day. Any learning that we do, it is almost forms 70% of our work. I given enough clues. 70% of when you go to office, what do you do? Not Google, of course, Facebook, okay. All of us do emails, right? I mean, I'm talking about a very productive work day where you have a lot of emails. You know how email spamming works? Spam. When something needs to be classified as a spam, it is based on history. How it does is, the first is set of emails are given, then it builds the spam keywords like offer, lottery, whatever, right? And then it learns from it, and then learns the probability of a particular word occurring together with some other word, then it labels as a spam. That's the way it works. And all this happens in sub-seconds. If you tell me that, okay, give me 2-3 minutes to process a spam, nobody is going to use this system, right? And this is what is learning. Very simple, intuitive example for you to go back. How a spam works is based on a learning model. And the next email comes, whether it's a spam or not, it uses probability. It uses simply probability there. So now, the message I would like to drive home in this is, if you want to really predict or test predictive application, learn probability. So without probability and statistics, it's going to be really hard for you to even understand what set of inputs, what are going to, yeah.
Sorry, I mean, if I'm derailing you, but what happens to the first email that comes? I mean, of course...
It may be labeled wrongly. It will be labeled wrongly. That's where unsupervised learning comes into play. When the first email comes, it's not a spam.
Correct.
But it learns from it. The first data set that you have, there's something called training data set and testing data set. I'm going to come to it. When you test the application, you can split the data into 2 parts and then build a training corpus, then the testing corpus. Okay, so now I want data now, right? I want data. That is what the whole thing is. Without data, you can't do anything. Without data analysis, there is nothing called testing in the predictive world, right? Now let's look at this example. How many of you recognize this? Who said Jantar Mantar? Yes. Jantar Mantar is good. Why this slide? But some of you ask when the prediction existed in the world. So the prediction existed even during these days. This exactly. This is basically a sundial. So the data, you may ask where I get data. The data is angles of the sun, and there is a model which is a dial, and there is something like a calculation they do, and it's an engineering marvel in my view, right? And output is to predict time. So again and again making intuitive appeal to you that whatever you see when you go out, it has a prediction part of it. And our ancestors have done this part pretty well. The reason of showing this slide was it's simply amazing how they built this dial using a simple mathematics calculation, and then you still go to Jantar Mantar in Jaipur or Delhi, you exactly see the sunlight falling exactly the time that you wanted to see. And it's a prediction model. And the model is nothing but the dial, right? Now, these are the problems associated with it. One is, it is non-trivial. As I said, it's not going to be UI testing or anything of this nature. It's going to be non-trivial because you need to know a lot of data. Then, it's data intensive, so you should get comfortable with data. How many of you don't look beyond 1,000 rows in an Excel? Have you seen 1,000 row Excel or more than that? Or 10,000 rows, whatever. And you hate it, and you use filters. You immediately go to filter. Show me the filter. Show me a pie chart, or give me a summary of it. Right? It's data intensive, so you should start loving data. Right? And data quality and processing. There's a lot of noise in the data. It's not the data that you don't like to use. Okay, and a lot of analytical skills. And I'll come to that a bit. Why we need analytical skills? I'll come to that a bit. Okay. What is the testing challenge? The first is I bucket into 3 parts: people, process, and tools. The people part is subjectivity and curiosity. Curiosity is something you don't get it. Subjectivity is something which all of us have. We say that, oh, this is not right, this food is not good, it would have been a little bit better. Curiosity is something which you would like to know beyond what you are doing, right? And in the earlier session you was talking about patterns. It's about going beyond what you need to understand. That's a people challenge, right? Second is experimentation and iteration. So if you are testing a data analysis application, you need to have a complete cult of experimentation and iteration. It's not going to come. If your project lead or a manager comes and says, okay, what is my deadline? So you need to just simply look at them and say that better you understand what is going on. because it's not going to be easy. It's not going to be easy. You don't have a timeline. We have a team of data scientists in my counterparts. The 30 of them, they literally don't have any time to work. Meaning they work at their own time, and that's the kind of a thing that we're talking about. And the last is the tools. It's not a UI work. It's not a sexy part of life. It is the most unsexy part of life. You'll deal with Python, a lot of back-end work, and a lot of spreadsheets. If somebody asks where is the output, you have maybe a graph to show or something. It is the most irritating for someone like a manager or someone to come and look at your work, right? Because you have nothing to demo, nothing to show. And more importantly, understanding the model is not easy. For example, when I talked about Jantar Mantar, it's not easy to understand how they built it. For example, WTC was much easier for me to explain. It's a simple model, but the model can get very, very, very complex. Right? These are the challenges, and how we're going to do it, I'll tell you. Okay, so I'm going to take the first case study. How many of you face this frustration of booking an IRCTC and SpiceJet? Annual say offer, Indigo, how many of you faced it? Right? You know why it happens? First is traffic, of course, many people go and hate this server. And other than this, something called availability. For example, when you're booking the same route, somebody else also looking at the same route and booking it, right? That's called availability. So my first case study, which since I work in travel, comes from that fact. Okay. So we call search quality monitoring. Basically, we have a system. What is the before I go there, if they answer the question, second goodie goes to this person. What is our attention span today? In seconds.
30 seconds.
As per research. What is the attention span in seconds? Just give a number. 27? 7? You said 7 or 27?
Only
7. That's right. What's your name, sir?
That is the universal voting time actually.
So basically, the attention span from our previous generation, so-called elderly, is reduced from 8 or 9 towards 6 or 7 now, thanks to mobile, right? So let's say you go to a website, a clear trip or make my trip or yatra, and then the search takes, let's say, 3 minutes. Do you think you'll be in the site? You'll probably look at some other site, right? So what they do is to give you a huge cache. I'm talking some programming paradigms here. A cache is nothing but a data set which can be accessed very fast, and it will give you sub-second responses, right? So when we do that, okay, I'll give you a very interesting example. We were with Qatar Airways. There is a person named Sanil Venkateshwaran writing an email to us saying that your product is bullshit, it doesn't work. Then you're thinking why it is not working, right? We use two parameters to compute this cache. One is called popularity. Popularity is about how much route is popular. For example, Delhi Bhubaneswar, Delhi Mumbai, Delhi Bangalore. Out of these 3 routes, I'm sure Delhi Mumbai, Delhi Bangalore is much popular than Delhi Bhubaneswar. I'm just giving an example because of the passengers or whatever, right? So you don't compute because you save cost by only computing this and then put it in the cache, right? But when you hit Delhi Bhubaneswar, it shows a price. When you go and click, it shows some other price. How will you like it? You will find this search is this particular site is bogus. You will feel that this search is not right, right? So another example which I come back to Qatar, they were searching for, our team sitting in France, configured all US routes. And they given 10 test cases. The first test case was Goa to Berlin. And maybe Indians travel from Goa to Berlin, I don't know, but Goa to Berlin was giving a 50% accuracy. What you see is 300, but when you book it comes 600, right? And then they given 35 test cases, and our response was very standard, right? We are all commercial companies. Our product is 90% accurate. So though they write it back saying that, yeah, that's great, but the 10% is what we use. Okay, so Goa Berlin is a great example. So this is called search quality monitoring. Let me load the slides. What you see, you cannot book. That is called the search quality. So we need to search whatever you're searching, you should be able to book it, right? And the KPIs that we use is findability, finding the same recommendation, same flight, same price. For example, I cannot show you Air India and offer you jet, and show SpiceJet and offer you Indigo, right? I cannot do that, right? And third thing is availability. All is okay, but I don't get seats, like SpiceJet frustration. You just click, it's not available, right? So how we wanted to monitor this system? So we built it's a more of a loaded slide since the technical session. So you see a file system cache, and there is a monitoring system. The booking system which you see on the top is the system which you have the real price or the source of truth. And we monitor this search quality, right? And I have only one intuitive question to all of you. It deals with 0.7 million messages per day. 20 odd customers use this. If Qatar comes, I should be able to tell this. And it used by travel agents, 3 products. How do you even test this? I'll show you the product and let's understand what you got. This is the search quality monitoring. As you see, there are tips here for a particular route. You see this ECG kind of a graph, right? How do you test this? I heard a lot of Selenium developers here. So they said, okay, I'll write a Selenium script to inspect this element and it is a crop, I'm going to send an email. It's not going to work that way. You need to really understand what it is, why it is, and understand something called smart sampling. You need to understand there is sampling technique, right? The sampling is about, out of millions of data that you have, you pick 1% of the data and test. And 1% is what really tells you the truth, right? So again, here comes statistics, advanced sampling techniques, stratified sampling techniques, between two routes or whatever it is. That's the way it works. And tell me something, after hearing this particular case study, how a conventional tester can work on this team. I hired a tester 6 months before, and he's right now almost coding. Almost. It cannot work in a kind of saying, okay, waterfall, okay, give all this application, I'm going to test it, right? You need to understand what model I'm sampling, why I'm sampling this, what are the things that I can infer from this, right? So this is what it is in terms of finding these patterns. So random sampling, which I told about, and you have to understand the logs. How many of you use Logstash or any of these log systems, logging, production logs, Logstash kind of a thing? You need to understand how to mine the logs and understand this particular record has this problem. Right? So how the testing agility in this case achieved, as I told, smart sampling, scenario prediction. So some of the times radical scenario prediction people come up with, a lot of unit tests. So as a tester, I need to know, as a developer, I need to know what unit test I'm writing to this. Without unit test, I mean, Rahul was talking about percolating the problem. Without unit test, is going to fail. Because nobody is going to believe your number. Qatar will send a mail again saying that, yeah, I'm the 10% locked. You're not factoring to my requirement. And a lot of pair programming. So we have a team of 4 members. They do test, and they do code, they do deployment. They do everything together. There's nothing like I have a role of a tester. So they have a little bit of a development effort, little bit of a testing effort, etc. Okay, lookalike production environment. I cannot say, okay, I'll come to the little bit. You need to test this, but you should have an environment to test it. And we call something like lookalike production environment, where it's exactly the data replica of what you have in production to test this. You should have exact lookalike coming up so that you can spot these errors. And the test suite is open, meaning anybody can contribute to this test suite. Okay, so that is making it a little bit easier. So, come to the next case study. You're a traveler going from, how many of you travel in flights? Okay. You're going from Bhubaneswar to Delhi. I'll give you 3 options. First option is 6 a.m. reaching at 8 a.m. non-stop, 3,000 rupees. Option number 2, 10 a.m. 12 noon non-stop, 2,500 rupees. Option 3, 6 a.m. reaching 4 p.m. one stop at Kolkata for 4,000. Which one you prefer and why? Option number 2. How many of you say option number 1? Option number 1. Okay, 4 people. Option number 2. Okay, good. Option number 3. Okay, I think you're missing the point. You didn't ask me a question.
Can depend on time.
Who said depends?
It depends on time, at what time I want to reach the destination.
True, but you're right. But still, why you need to reach on that time? Sir, I think you're a speaker. Let's say you have an engagement in Kolkata. Let's say. Third option looks much more appealing to you. Let me give this. You didn't ask me the right question. The right question to ask is what type of traveler I am. What type of traveler I am, okay? Let me give you an example. The first option will suit for somebody like a couple going on a vacation. They don't mind getting up early, 6 o'clock, and maybe Lohit will be doing. A Bangalore airport is like 2 hours away from our place. You get up at 3 o'clock, and you reach the airport at 6, and it's a mess. Okay, you lose your sleep. You feel like you're a zombie.
I don't take that.
So the second option, as you see, is about family, which is much easier. You have kids, you cannot wake them up as well. So second option is much suitable for families. The third option is for business traveler, like the speaker here, who wants to give us lecture in Calcutta and reach Delhi, for example, right? So you need to ask what kind of customer it is, and that's what we deal with every day, right? And this is called customer choice modeling, CCM we call. And customer choice modeling is about, if you're given 5 options, which option will pick? And 5 options picking is a probability, right? Because you cannot say, I'll give you an example where it helps. We had an interesting problem with our competitor Sabre. Sabre is another travel company. The competition is that number of bookings that you do on a 10% traffic. Let's say they'll open up the server for you for 10% to save the 10% immediate. The number of bookings you make on that month, you get the 80% traffic for the next month. Which means that more number of bookings you make, you can get better deals or better things with the customer. And multiple times we used to make the joke, if Sabre loses a particular day or have a network outage, we rejoice because we're going to win that day, right? And it happened 17 months, not 1 month, 17 months, right? In this kind of environment, how a tester can even thrive? And you're talking about terabytes of data to crack. Terabytes of data coming into the system to crack. They give you search logs, they give whatever you want, but you have to crack it. How we cracked it is, this is a little bit of a slide on data-driven search. We do a lot of parameterization, and as you can see, we do a little bit of analytics to predict the customer profile, what sort of things that we need, etc. I'll give you an example. So the first one is convenience factor, knowing the traveler profile, which I talked about. Weekend getaways, business travelers. Business travelers love to leave on Monday early morning, return back on Friday evening. Right? You have to give flights to them, right? And low-cost carrier options, like for example, Lufthansa has a low-cost carrier called Germanwings. In India, you have a low-cost carrier pretty much coordinate. Free baggage recommendations. People take baggages, so you give free baggage recommendations. And testing all bookable combination is complex. It's impossible to do, right? And the data is available real time, and also predicting the origin destination is something. So this is the slide which I talk about. The left-hand side, whatever you circle the pattern, is the fastest and the cheapest. Most of us wanted a fastest and cheapest given a choice, right? And you see the number of recommendations there is very, very less. In the second one, you see the pattern number 2 has middle fastest, like 2 times fastest, but it's pricey, right? So after we do this customer choice analysis and crack the data that we have, our number of recommendations goes up here, right? And we do this every day. We do this every day. And as a tester in the team, you have to be like a data scientist wearing multiple hats. Throw the hat away. Today I'm a data scientist. Now I'm a tester. I'm a release engineer. I'm a developer. You wear multiple hats. And the team size is only 4 people. They're not going to give a big 40-member team to do this project, right? So this is the pattern, okay? So how the testing agility is achieved? So we have something called A/B testing. How many of you do A/B testing? Heard of this term, A/B testing? Heard of this term? What is A/B testing, sir?
Basically, it is having separate versions of the same product that is given to the customer to use, and they are able to get a
and ultra fast release. Almost the release is every day, and you're doing release every day. Then I heard regression testing, functional testing, all those in the previous session, where you run regression and say wait, I'll wait. Release after 36 hours, and by the time Sabre gets over it, right? So it's ultra fast release, and you need to make it a little more relevant. And the tools that we use is R, Beta, MATLAB, Python, and Hadoop. Basically, just for you to little bit understand what tools we use. And as a tester, you would like to go more towards it. These are the tools to learn. This is an interesting case study. The last one is called Rail plus Fly in India. Rail plus Fly is a concept where we are trying to do a combination of a rail and a fly combination, where you fly from a tier 1 city to another tier 1 city and go to a tier 2 city, right? And Bhubaneswar has a good flight network right now, so I don't want to take Bhubaneswar as an example. But let me give an example. So we have a tier 1 city, Mumbai, tier 1 city is Chennai. There's a place called Coimbatore where I studied. It's a tier 2 city, okay? So the first option is you fly to Chennai and then take a train to go to Coimbatore, okay? And the options are, it's like the price is around 5,000, 3 hours is a flight, 20 plus flights are available. And you need to come, take a transit of 1.5 hours. Then you go towards Coimbatore for 6-7 hours of train. You see the total price. And airlines have exploited this, and they have 5 flights for 8,000 rupees, 3 hours. And you see the convenience factor, right? And given a choice, let's say it's given to you, how do you even model this or test this problem, right? So because this is a real tricky problem for you to solve, because not everybody earns 8,000, or what everybody can afford 8,000 in India, right? So we are interested in this kind of problems, and we do a little bit of network analysis. This is the recent innovation, or recent means like 1 year before. Rail, if you are in rail wait list for first class, they upgrade you to LCC like Indigo, SpiceJet. These are innovations coming right in front of our eyes, right? Where Indian Railways and airlines are collaborating. The other one is if you come to Bangalore, you get a straight bus to Mysore. You don't need to go to the city. You get straight the bus to Mysore, fly and bus, and you can book while you're booking your ticket, right? So this is a bit of dynamic pricing. How many of you use rail booking dynamic pricing? The price changes, dynamic pricing. So the dynamic pricing is based on a research work by IIT Mumbai, done in 2007, okay, 2007, and they implemented dynamic pricing 1 year before, right? Where the price changes at the last minute, okay? So my intuitive appeal to you is, how do you even test this route dynamics? How do you even predict the demand? And how do you model and rationalize such networks? You're talking about network problem. The first problem which I talked about is about the quality problem or a search problem. The second problem which I talked about is customer convenience problem. The third problem is about network. These are three different problems. And in my view, I think I have a feeling that unless you understand the model behind it or the underlying principles or the mathematics behind it, it's very hard for us to test. Because Rahul was saying, you can question the developers, saying that how do you do it? But as a tester in such world, it's going to be a bit harder for you even to go and look at every line of the model, how it is coded, unless you do it. Because reading a design document, I don't think so you can get anything out of this. Because it's going to be really hard for you to understand this particular part. Okay. Now, when you walk out of this room, I would like you to think about these things, and very importantly, to walk out as a tester and you want to remodel your career towards predictive application or big data applications. This is what you need, or this is what the traits that you like to have. The first one, redefine the roles, different hats. You need to wear different hats. You cannot have one hat and say that, okay, I'm going to do only regression testing, or I'm going to wait for the build to come. It's better you go get the build or build it by yourself, right? You have to redefine your roles. The second one is intelligence and intuition. There is a study which says that robots will take over humans. You know what is the estimated time they have? There is, again, people who are pro-robo, or people who are anti-robo. The pro-robo group tells certain time period. Any guess how much is it? That is called a year of something like unity or something like that, where everything merges to the machine. What is the time frame they're looking at, scientists? How many years? Who said 40? Any other numbers? Yeah, I mean, all this AI, everything is a movie, but I think it's real. For example, today Amazon tells you buy this, right? So it's in front of us. Any guess? It's not 40, somewhere. It's 25 years from now. They predict 25 years. Okay. So the thing is, when the intelligence and intuition, I mean, machines are good in breaking down the problems further. Okay, but human mind is good in putting this problem together. We call big picture. Understand what it is, right? So human mind is good in doing that. So when you're a tester or a programmer in this space, you should have a good sense of intelligence and good set of intuition. And you should back it. It's not possible for you to say only by rationale it works. But you should say, I think intuitively I can do this experiment a bit, etc. Right? So third is creativity. There is no substitute of creativity. So in this world, innovation, and I think Siddharth talked about, it's all in creativity. If you're creative, your model is good, you can prove anyone wrong or prove anyone right in that regard. And adaptability, you should have the flexibility to learn new things, ARM, Pekka, whatever tools I told you, and the data sets are pick the problem. And multi-skilled, which we talked, and also the time value. The data that you see has a time value. You cannot say that 5 years before data and say that I'm going to do this, because a lot of data that's going to elapse the value. What are the things that you've done an experiment 5 years before? Does it really hold good today? No, because a lot of things have changed. There is a time value for prediction, time value for data, right? So many people ask me after I talk this, where to start? Where I should go and start? The first thing first, maths and probability was there with us, okay? Indians were too good at it, okay? And we lost it, unfortunately, okay? And any grad exams that you get, GRE, GMAT, Indians top it, not even Chinese, Indians top it. And when you come to IT, it's gone. Today, when I talked about name-based, projectile, these are all basic things that we learned. So we had to learn the basics a little bit when you want to learn about the machines, because machines are going to learn from us, right? Read a lot. So there are a lot of intelligence that's coming from Facebook, AI, TechCrunch, Mashables. Facebook is good, but you should read proper things. So these are the things that I recommend. And if you want to start really about machine learning, you can take Stanford or Coursera. And more importantly, open government data sets, that is by, with the recent government initiatives, you get a lot of data from data.gov.in. Please note it down. You can go and pick one problem and solve it today. It is called data.gov.in. You can request data sets. You can ask the government, I need this data. For example, the rail and fly case study was from data.gov.in. And I didn't get any other data sets. So people say that where is data? And Jantar Mantar is a great example. It's the data is there. If you want to really study, you can study that, right? And there is a website called Kaggle.com. If you do hacks, hacker kind of a thing, Kaggle is basically the data science kind of a website. You can go and look at problems where you can solve this. Go to Kaggle. You can learn or you can experiment. A lot of tutorials available for you. And more importantly, last but not the least, you should have a passion to solve a problem. And data is required for you to solve the problem. That's the way you should say. The fundamental quality of mathematics, probability, and problem solving combined with the data is going to make you powerful. And I take pride in what you call being part of the community where it's like a maths and the things were part of our ancestry. And when you kind of revoke it again, when I talk to people who I mentor or someone, they tell that this is what I learned in the school. I said, so far what have we doing? So basically they've forgotten it or we modeled that way, etc. So you should have the thirst of learning maths. And this is the last one. I don't know whether another third one prize is there, but I request them to give it. There are green dots with ears. I want you to guess x-axis, y-axis, and what is the problem. Have a closer look at it. There are green dots and there are yellow dots with ears. And I can give you one clue. It is something very close to our livelihood. Any guess? What are those green dots? What are those yellow dots? And what they represent, x-axis and y-axis? Take a shot.
Year and earning.
Year and earning. I told it's for a livelihood. You can still live without a livelihood. Somebody will support it.
Crop produce?
What is that?
Crops produce in years.
That's nice. You're close. I think he has given a clue. It's related to crops. Why we need crops?
Food. Food agricultural produce.
No, that's fine. For crops, what we need?
Water.
Water. For water, what we need?
Rainfall.
Rain, exactly. So, okay, you got it right. What is the x-axis, y-axis in that way?
One would be in millimeters.
Rain?
Rainfall in millimeters.
Okay, I give it to you. You can give your name to the organizers to get a goodie. Okay. So it is basically the monsoon prediction in India. This is not my slide. This is a slide by IIT Mumbai professor. He said, I just open it. So it is, since it's why it is complicated is, as you can see, the yellow dots represent drought, okay, and the blue dot represents flood, and green dot represents normal. As you can see, year 1982, El Nino's strength was very high, 1962, so the monsoon was very bad. But you take year 1997, El Nino was high, but the monsoon was good. So if you attribute everything to climate change, you will not. And this problem is still unsolved. And this is the data set we are talking about. And this is the research by IIT Mumbai on how to predict a monsoon when the climate change or El Nino happens. And this is right in front of us, affects more than 70% of our country. And monsoon prediction is no mean or a trivial thing. And I leave you with this thought. Problems like this are open for you to explore. And this is the right time for you if you want to change your career from tester to data scientist also. Just making a wild thought, okay? Thank you. Any questions? Open for questions. So two things can happen in a presentation. If it's completely clear, no questions. It's completely unclear also. That's what I have. Anything that comes to your mind? I'm still curious to know what it is.
I have
Yes, they are. They are actually based on this candlestick patterns they form. I think you might be knowing if there is a 3-day moving average has been broken, the stock will reach this price, etc. So it is based on the prediction model. If there is a moving average, when the moving average breaks it, then there is a good chance that it goes up. So it is yes. The answer is yes, based on the algorithm. Anybody work on trading here? Trading applications? you work on trading applications? Prediction of trading? Not much. Only test the application. So any other questions? Or is it confused more or thrown another jargon at you?
When you start learning,
Naive means he doesn't know anything. It uses prior probability. It's one of the fastest algorithm available on earth. One of the fastest. If you give this prior probability computes, you'll be able to get more than 95% accuracy. That's the reason still people use it. Email filtering uses naive Bayes. Fraud detection, when your credit card is coming up and you're doing a fraud transaction, uses naive Bayes. And you are putting your money on a naive Bayes. $3,000 money running an algorithm on naive Bayes. So naive Bayes is a very successful algorithm, and it's pretty old algorithm. And another book I'd like you to read is called Startup Nation. It talks about Israel. Okay, there's a book called Startup Nation. You should read it. And to give a simple example, there is a company called eBay. You may be knowing eBay. So the eBay's founder Meg Whitman was being told by someone to talk to these 2-3 guys who are very young chaps. It's been 2004, 2005. So these guys came to the headquarters and they said, we are very good in fraud detection. This is our algorithm. This is what we did, and this is your result. Then he called his data scientist team, or lead of the data scientist, and said that, can you look at it? These guys predicted 10% more accurate than homegrown guys, right? So you should read this book, Startup Nation Israel. It talks a lot about Israel and how they are pretty much mathematical in nature. And my counterparts whom I work in my company are all from Europe, are highly mathematically trained or algorithm-based guys. So, and as I said, when we read in a computer science or any of these things, we read it as a notionary thing like Reddit, okay, fine, it comes in the first question we might have asked is whether it will come in the exam or not, right? And then we never understood when it can be used. So when you use some of these studies like naive Bayes or random forest, for example, it's pretty common. And the good sign is now India and China are the leading pioneers of some of these data scientist related work, and with this new initiatives we can take it. So any other questions? I think I'm standing between you and the lunch.
I have a question.
Example, but there's something called synthetic data. Typical problems with that. Python is interpreted, so it's much faster. So you use most of the data scientists use Python. And for database, you may be knowing they use Impala. Even HDFS are all out of way. Right now, they're started using Impala and few other modern database. For the data ingestion part, where you're having 1 terabyte of data, use Spark or Kafka, those kind of tools. So you need to think a lot of non-relational tools, but the language part is Python. You need to learn Python. So basically, when I went to France 2 years before, he asked me, Hari, there is a scientist who has a 30-member team. He asked me, Hari, how many people in your team know Python? I said, 1. I said, I throw you a challenge. Within 1 year, I need 5 Python guys. So what we typically do is that come hire for Python now. So it never happens that way. The person who knows the language also need to apply the same language into the problem. So basically, you need to reskill the existing guys. You cannot say that, okay, Java is the end of the world and then finish. So you need to probably rebrand yourself. You want to programmer also, or a developer also face the same problem, like tester. Because the new technology comes much faster, hits them faster than the testers. Okay? Thanks for your time and attention, and thanks for Tech Bhubaneswar and the organizing team. I hope you enjoyed the session. A little bit of awakening on your mathematics. If you walk away with pride that we are good in maths. Thank you.